Hi. In this example, we're going to be evaluating and finding the 6 trig values of theta in standard position if the point 5, negative 12 is on the terminal side of theta. Okay? Let's take and just draw up a quick sketch of what we're going to be looking at here. Let's find that theta value. So, quickly draw out your Cartesian plane, where here we have x and here we have y. We're looking at a point positive 5, negative 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 5, negative 12 is right down here. So, as we draw our line going from the origin down to our point 5, negative 12, let's identify our theta value. Now, theta's value always starts on our initial side, and it's always a positive value, so we're going to wind all the way around here to get our value here of theta. So you can see that it's more than 3/4 of the way around. It's more than 3 pi over 2, which is that 270 degree mark. Okay, so it's more than that, but it lies right out there. So for us to find our 6 trig values, here we have again x, y, and we need to find r, that value that goes from our origin to the point 5, negative 12. So, as we see in our formula over here, r is equal to the square roots of x squared plus y squared. So let's take and solve for that. R is going to be equal to the square roots of our x value squared, or 5 squared, plus our y value squared, which is a negative 12, that whole quantity being squared. So r is equal to the square roots of 25 plus 144, which gives us r is equal to the square roots of 169, or r is equal to positive 13. It just happens to work out that way. Okay? So r is a 13 value. To find the sine of theta, again, that's always our y value divided by the r value. Y value is negative 12, and r value is 13. So the sine of theta is negative 12/13. The cosine of theta is always our x value divided by the r value, provided r is not 0. So here we have 5/13. The tangent of theta is going to be the y value divided by the x value. So here it's a negative 12/5. That takes care of sine, cosine, and tangent. Now we need to take care of their inverses. Again, from your reciprocal identity practice, we should have down that the inverse of sine is cosecant of theta. And cosecant of theta then is going to be the inverse here, or a negative 13/12. Okay? The cosine theta inverse is going to be secant of theta, which is going to give us 13/5. And lastly, the inverse of tangent, as you may have already addressed, is cotangent. And cotangent of theta is going to be negative 5/12. Okay. So there we are with our 6 trig functions for when we have the terminal point 5, negative 12 in our standard position. Okay?